Hi, my name is Pavlo. Today I want to present to you the first version of our developer terminal. This is a beta version designed to allow developers to create their own web agents. STELS is now being assembled into a unified ecosystem. The key feature of STELS is role-based access control. As you may remember, STELS is a decentralized, heterogeneous network that performs operations, and not just operations. It's building a distribution network, enabling you to create anything you want, literally, visualize it the way you like, and automate it however you choose. STELS is pure Web 3, but today we're experimenting with calling it Web 5, because it uses the most advanced technologies and standards of the new generation of web protocols. We've built a system that's not just another wallet or blockchain. Those are like children compared to what we've created. Let me explain why. First, it's an ecosystem, a platform where you can be both a developer and a user. Most importantly, the philosophy of STELS is built around the idea that you can be both a developer and a business owner, especially in the context of automation and modern artificial intelligence. STELS is collective management, a heterogeneous network, and a form of large-scale artificial intelligence, an internet within the internet. It's built entirely on the web, so everything you'll see is web-based. There are no other technologies here. All you need is a browser to work with web technologies and build a complete infrastructure based on open standards for management and automation. This video is especially important for those who will receive the first nodes from our team for application and automation system development. Our goal is to demonstrate strong results and deliver meaningful outcomes to our investors, as well as to our friends and partners, and to change the world of the web. Access to the platform is provided through a single entry point, only via a crypto wallet. I call it an identifier, a web ID or DID, decentralized ID, issued to you through the standard process of key generation. Your wallet is generated automatically within the network, along with a map. I'll explain later what it's for and why it's important. Everything we use is purely web-based. We use the internet as a runtime engine, leveraging all web APIs and technologies to create a decentralized control system. Essentially, an internet within the internet. These are web agents, and once you enter the system, your web agent identifies you and immediately understands what permissions you have in relation to the node you connect to and the network you join. The main source of identity is your wallet. Everything is built on your private key, generated using classic Bitcoin-style cryptographic methods. The distribution system is spread across nodes, which means the network is fully decentralized. And it's important. When you receive a development node, first of all, we need to know who you are. We want to understand who we're working with during the initial phase, while we're still testing security and various aspects related to runtime. STELS is a decentralized web OS, a web operating system for building autonomous AI agents, your own web agents. We currently call it STELS Web 5 Platform, an experimental format we're actively testing. Once you generate your wallet or save your private key, you can access the network using that key. Then you'll need to choose a network. We're preparing the testnet for public release. We're cleaning it up, configuring databases, and deploying nodes so you can connect via your terminal and use the system in the testnet environment. For this demonstration, I'll be connecting to the local net to show you the main functionality, building AI agents, web agents, and web tokens, developing interfaces, and everything related to the decentralized web. My node is currently deployed in Docker. You'll receive the same Docker setup, and we'll provide network keys so you can deploy your node and connect locally to the platform. Once connected, you'll enter the HUB. What does that mean? It means you're in the Web 5 Developer Lab, a space where you can build autonomous AI agents through our technologies, schemas, and protocols. Right after joining, you'll access your personal web store, where all your agents are managed and displayed. To become a developer, you'll need to submit a request for a node. You can be a node owner within the distribution network, or submit a request via the protocol development system. You can also send a request directly to a node administrator to gain access. Once the request is sent, the node developer receives a notification, verifies your signature, and if everything checks out, grants you access to the node along with tokens so you can start working. In this case, I'm using the 0 node, which is freshly deployed, and this is exactly how it would look for a regular user, not a developer. A regular user will be able to access your web agents and use them for a fee. You, as developers, can create and sell your agents through this web store. This is essentially a store of web agents. Developing an agent means creating an automation agent, a protocol-based AI that enables full process automation. It's a form of artificial intelligence that allows you to use modern web technologies, reactive UI, web standards, and Web 5 protocols to build intelligent, autonomous systems. Let's talk a bit about documentation. Here you can read all the materials. I won't go into too much detail right now, but you'll find a lot of useful information. What technologies we use, how the web was built, and why STELS exists in its current form. The key point is that we have identification and identity control. You own all your data. All applications in the system are decentralized, and we use the most advanced web technologies that can be accessed directly through your browser. Today, you'll see a professional terminal system built entirely on the web. It's lightweight, fast, and communicates with your node through a seamless infrastructure, allowing you to develop anything you want. We'll discuss this in more detail later. The developer documentation explains our tone, the structure of the system, and what types of applications you can create. For example, you can build trading agents, work with the intelligence network, perform data aggregation and collective analysis, create network operations, and even develop custom APIs. We'll go through all of this in the documentation. This application is your tool for working with Web OS. Web OS is essentially the STELS runtime, a visualized interface that simplifies a complex backend system. From a developer's perspective, STELS is a powerful runtime engine performing high-speed operations inspired by high-frequency trading systems. It's not just about aggregating or collecting data. It also involves script execution, where every operation is not a smart contract, but a smart transaction. We don't use the traditional blockchain model. Instead, we've implemented a monochain, a continuous transaction stream that never ends. This means there's no need for block revalidation since we preserve the chain structure rather than storing heavy data inside smart contracts. As a result, you can build any kind of application connected to your web contracts, ideas, or systems, all through a single interface, the Web OS, which is STELS. STELS combines multiple technologies. First and foremost, the runtime and network. To work with the network, you need a way to visualize and interact with data, and STELS makes this possible. You can both receive and send data within the network using standardized formats for full interoperability. For instance, you might want to create a professional dashboard for your agent that manages your assets, and you can easily do that here. Today, we'll walk through the entire process together. I'll show how to build smart contracts, smart transactions, how workers function, how they're deployed and integrated into the network. You'll see all of it in action. Additionally, we've developed a schematic reactive UI system that allows you to visualize anything you want, exactly how you want it, giving you, as developers, full creative control. All right, not your client or anyone else, for example. If you're creating a solution for your client, managing assets, or automating workflows, it doesn't matter. It could be a factory, a port, airplanes, drones, or a delivery system, anything. You can build a control panel for full infrastructure management and share it with your client or supervisor, distributing access rights securely, and it's safe, because it's pure web, no servers involved. STELS operates on a serverless architecture. Hundreds of distributed nodes across the globe, dynamically connected and synchronized. They communicate with different data sources and with each other to ensure minimal latency and a stable, reliable data infrastructure. That's crucial. STELS empowers both developers and end users to build and run decentralized applications seamlessly. Now I'm logging into the network using my developer account. This account has access to a node through a private key and is included in the node's whitelist, allowing me to program freely. Functionality of STELS and web agents. The main idea is that each web agent is stored locally. Here's our test wallet. Some of you may have already seen it in previous demos. Each web agent is an isolated runtime program that executes in the network through all participating nodes. It processes a massive number of transactions and operations distributed across the network. We'll go deeper into that later. Today's session will take roughly an hour. After logging in, the system checks your developer permissions. If access is granted, you enter the main workspace with a left side panel containing tools like the protocol editor and smart contract editor. On the main page, you'll see your agents, which you can later publish to the web store, where users can access or purchase them. You can think of it this way. Websites are evolving into web agents. Traditional sites are being replaced by interactive applications. STELS is built on the latest progressive web application, PWA technologies, data streaming, and socket-based synchronization. This creates a unified, distributed system where all browsers in the network collaborate, using their runtime environments to execute operations. Every computer has its own runtime, an engine where your scripts can run. Developer interfaces. Developers have access to several key interfaces. Hub, your main panel to manage and build agents. Web Store, the marketplace for your agents, accessible to end users. We'll explore these tools further in the next section. Here we have documentation and schematics work. I will explain how it works next. There are also protocols and a workspace visualization where you can create dashboards, applications, and web agents. Your web agents can take various forms. They can exist on an infinite canvas and interact with each other. One agent sells assets based on certain rules, another agent buys according to other rules. You can create as many agents as you need, hundreds or thousands. The number of network operations and their cost is up to you. A node can be executive, connected to the network, or local, fully isolated without internet access. This allows building web agents for smart cities, smart homes, automated car control in your garage, or any other scenario. Right now, we are exploring market operations, high-frequency protocols, and financial protocols to understand how the system works. The left panel contains the same tools as the main menu for quick access. UX and UI will be improved in the future for greater convenience. Main tools, Canvas. Main space for visualization and agent management. Editor for editing protocols, schemes and documentation. On the right, there's a theme switcher. Default dark system theme or light theme for comfortable working. STELS operates on a reactive UI, tracking almost all actions in your browser. I'm using the dark theme for demonstration purposes. Connection panel. The connection tab shows which node you are connected to. Valid node address, your wallet, and the network map. User status. With disconnect, temporarily end session, and logout. Clear all local data. Cookies, local storage, sessions. In the bottom right corner, the node status shows number of completed operations, earnings, network economy, node ID, errors, penalties, average execution rating, number of active workers and smart contracts, network synchronization status. This is important because each node is programmed once for your VP agent, and the agent can run autonomously in the network even if the node is offline. Keep in mind that you won't earn immediately. Your web agent will take a small commission for executing operations on other network nodes. Currently, we are in dev mode, and you can already start building your first web agent. Key points to understand. Each web agent is a living unit. You program it with your own protocols however you like. Functionality depends on your knowledge. Network operations, protocols, system connections, smart contract logic. We chose JavaScript as the primary programming language. Web native, typed, secure under the hood, TypeScript is also supported. In the future, we will add Rust and Lua as options on request. For now, JavaScript is the most popular among STELS developers and works reliably. Main elements. Filters by contract, transaction, or worker status. There are modes. It can be an exclusive worker, your agent's contract, a parallel worker, or a worker assigned to a leader who continuously executes it and receives payment from you while you receive payment from your users who use your application. This creates a dynamic distribution system so you can deploy agents and continue with your own work. Worker overview. Interface interaction. Building the first application. Web tokens. Programming, smart contracts, no extra software needed. You only need web technologies to build any application you want. Example. Today, we will build a monitoring system as an example. A client wants to see market tickers, or we create an app to display data to the user. To work with market data, we will use a market monitoring system, a pre-built contract development template. Next, we will dive into building the market and monitoring functionalities. The first thing to understand when developing a contract, in this case a worker, is that you can immediately designate where to deploy it. In this case, we will deploy it to a local network, as the testnet is not yet enabled for public use. The local node automatically designates a leader who will use this contract. You can set the worker's execution speed in the network. The faster it is, the more expensive it will be in the future. Currently, we use the standard rate, as the network economy is still being built. There is a dependency version used for our smart contract engine. Important: we do not use Solidity, Ethereum, or other external blockchains. The entire platform is built on web technologies by our team with no third-party components. In this case, we are building a worker for monitoring. The first worker will connect to markets, fetch tickers, and execute operations. Glycerum will be used to sign transactions, but other blockchains like Solana can be used. Ethereum is currently not used due to slow performance. When creating a smart contract for a worker, you can assign an account to it, but this is optional. This feature will be added in the coming weeks. Each account has a unique network identifier, which allows the VP agent to know which account it is working with. Once the worker is created, we immediately see its code, a template we will expand later. Right now, we are showing the main system functionality to quickly build the required application. The worker will handle tickers. Each script is not a server. It executes the node protocol operations via all possible web APIs. You can fetch information, connect sockets, combine them, and execute operations within a single program. This program can be deployed to the web network and will run. Next, we will show examples of workers that you can fully work with. Alright, so this is our worker. In this case, first thing, its scope is the local network. You can switch it to migration mode once you've tested it locally. This is basically a smart contract. It's running, everything works fine. Once it's ready, you can push it to the network and it will run there. For now, we can just mark it as leader to build this worker. We can also set its mode. There are two types of worker contracts. Loop contracts. This means the engine checks your operation every microsecond and runs it. It keeps checking and running in an endless cycle. But it's smart. It knows how to distribute the load in the network so no node gets overloaded. Single contracts. This runs once and does nothing else. It's like a program that executes a single time. Inside it, we can still loop with custom timing if we want. We can also specify which node it will run on. In this case, it's a single worker, executed only by the leader node, our node. It has a dependency and a version. I'll save it, and we move on. Next, we have its prompt. Here we can write the instructions for the worker. Why is this important? Because under the hood, the system has an LLM. Let's say I write tickers pack. We'll go over what this means later. Right now, don't worry about it. The LLM is built from our heterogeneous network. It's a collective intelligence. Every web agent knows about the other web agents, and they can communicate. You can share info with other agents as you want. It can be like a collective organization of your agents doing tasks together. This is super important for decentralization because STELS is a fully decentralized network. Next, we have logs. This is the console where you see what the worker is doing. If it's a networked worker, the leader node is displayed. Right now it says there's no leader because we're on a local network. Now let's create the first script for this worker. We'll use logger. Logger. Check the SDK documentation. It collects info, isolates it, transforms it for the AI to understand what happened under the hood, and provides optimization recommendations. As developers in the foundation, we'll read these recommendations to see what worked well and what didn't in the network. So we take logger, give it some info, and write the first line. Hello, AI web agent. Since this is a single operation, it runs once. I'll save it, go to logs, and run it. On the right, there's a small button to start or stop the worker. It'll appear once I launch it. Migration to the network. This is basically a build, so your program, your web agent, starts running in the network, but we'll get to that later. When we click Start Worker, it starts working, and it's running now, see? In the console, you can see it has executed once. It keeps running, though right now it looks like it's just waiting for something. Look down here. This is important. You'll see that only one operation was executed, and the worker is in a sleeping state. Why does this matter? Because if we give this worker an internal loop, we'll need to monitor it and track how many operations it performs. Right now, only one operation was done, and one worker is active. If I turn it off, the worker goes into stop, leaving the working state. In the stats, we can see we have one worker, one contract, and we can work with it. But remember, contracts and workers are different things. Later, we'll talk about how to program your web tokens, wrap them into real assets, and build more complex structures. For now, let's focus on working with the interfaces, specifically the developer terminal interface, so you start to see that we're moving forward. All workers are asynchronous and parallel. It's important to understand. In STELS, everything runs in parallel and asynchronously. Thanks to static information exchange protocols and decentralized consensus, we don't need a heavy blockchain. We can work with an efficient consensus instead. Since the worker is parallel and asynchronous, we can tell it, await, because it's an async operation. STELS has its own SDK, and we can use different services. In this case, we'll use sleep, basically sleep for 1 second. When the worker sees the sleep function in a single contract, it runs it in its isolated environment. It doesn't use the global loop because the entire loop runs in the node's global runtime. Here, it works in its own small closed environment. If we save and start it, in the logs we'll see it performing an operation every second. Oops, a small clarification. We need to wrap it. We can do this with a classic while loop since it's single, not loop. We start it and watch in the logs. Now the agent performs some operation every second. We don't know exactly what yet. For now it just says, "Hello AI web" every second, and this worker will already show the number of operations at the bottom. The network and the node calculate and update this every 10 seconds. After about 10 seconds, we'll see how many operations this worker has performed. But here's something important to understand. A loop worker, the one that runs continuously, is only executed once. That's right, just one operation. You launch it once, and it keeps working. You're not paying for every operation your node performs, as long as it's running in loop mode. Let me show you how that works. I'll go into the configuration and lock it in. I'll save it, remove the while loop, save again, and run it. Now watch what happens. Operations start running. These are now network level operations. You can see the logs appearing here and you can track them by time. Now it's using the loop worker, executing based on the sleep value I've set. If I don't specify any sleep, it'll run every millisecond. Let me show you. This is going to be very fast, so just watch. Once we start it, boom. Look at that. The UI can't even keep up because it's running insanely fast. Basically microseconds. We don't want to overload the system, but you can see we've already done 6,000 to 7,000 operations in just a short moment. It could go even faster. You can boost performance with boost mode, but we'll talk about that later. All right, I'm stopping it now. We don't want to waste more resources. We've just performed 14.5 thousand operations. Now I'll switch it back to single mode because we're about to start building the app. Why single? Because I'm going to paste a ready-made worker. Later, we'll create our own different ones, but for now I'll insert an active worker that connects via a socket to an exchange and receives live data. We'll get to that later. For now, let's stop here and move forward to better understand the interface. So, this is where we build contracts. They can be different. We can work with Telegram bots, various APIs, database backups, price aggregation, system health checks, WebSocket monitoring, and more. You can build grid strategies, DCA strategies, arbitrage monitors, position monitors, market and balance monitors, pretty much anything. There are already over 200 contracts built into the system, not just workers, but core contracts that power the entire network. All of these will also be open source, and we'll talk about that later too. So far, we've executed 14,000 operations, and technically we haven't even done anything yet. Let's move on. If we close our app, we have a visual workspace, a protocol editor. That's where we just were, writing our script. And we also have a visual workspace here. There's also a schema manager, but we'll get to that soon. Now let's talk about the visual workspace. The visual workspace is basically an infinite canvas. You can see those dots there. That's just the canvas background. This canvas includes something called the widget store. This part is made to make it easier for you to program your agent. Let me explain. Right now, we're connected as a developer to a node, and there's some runtime data here called Sonar. Let's take a look. When we open it, we see a bunch of numbers. They don't mean much yet, but we'll go through each of them later. Everything here runs in real time. You can see how STELS is updating. Here's the info about your node. How many operations were just completed? For example, here we can see 14,400 operations displayed. There's also the average operation rate, which shows that our node is working normally, processing data through GPU or NPU and sending it to the AI system. Next, there are the node keys. Let's open them. Here we have lots of detailed node information: CPU, peers, node location, network, title, memory usage, timestamp, ISA, UTC, even some copyright info and details about the engines that power the system of heterogeneous nodes. In this case, the system uses the Dino engine, the V8 engine, and Rust along with TypeScript to keep everything strongly typed, static, and safe. All right, moving on. You'll start seeing more runtime data appear here. For example, let's take a look at the network monitoring section. What's that? It's a feature that shows how many clients are connected to this node. Right now, we're connected as one client, so it shows just one active connection. But I can also connect to the same node from another client to demonstrate how it reacts. Let's do that. Okay, I just connected, and look, it shows that another client has joined the node. We now have a connection count for all sessions. We can see each active session in the network, who's using it, what device and browser they're on, and other details used for security. Then there's the data transition interval. That's the time interval for sending data to the front end. Inside the network, we work with milliseconds and microseconds, but on the front end, around 500 milliseconds is enough for development and smooth performance. There's also a heartbeat interval, a full system check every 2 seconds. And cleanup running, a process that clears cache to prevent overloads. Now, what else do we have here? We've already looked at the runtime scenario. Let's check the worker section. This is the worker we just created. See? Here's what we can observe. The full info about the worker, the script, which is empty for now, its current status, inactive, single mode, local scope, execution mode set to leader, priority is normal, node data, tickers pack, version, and other parameters. So if we go to the editor, and inside the worker, we add some script. For example, a simple comment, hello user, and save it. Then here in the runtime scenario on the canvas, we instantly see this information rendered in real time. If we launch this worker, the data in our canvas, in our system, will start changing too. Right now, the need flag isn't set. I'll explain that later. It's part of a dual execution protection system. It's a serious feature we're working on right now. Basically, it's a proxy layer that lets you run operations across different nodes that know about each other in the network. Some of these nodes are prioritized, for example, by speed, for exchanges or other purposes. It's all about network data security. I'll cover that in more detail later. Now we can add this data here. We can add it as widgets. You can move them around, rearrange them. It's a lightweight service for working inside the canvas. You can basically build any kind of control panel you want here. Later, I'll show you how to do that. We can add widgets to either a local store or a network store, depending on what you need. Right now, it'll be local. Later, we can sync it to the network store. So let's start adding some information. We'll begin with our first worker, just to save time. Since we're working with tickers, we'll take a ready-made, optimized script. It's a single worker, because it connects via WebSocket to the Bybit exchange. It just connects through that socket and pulls the tickers to build a full infrastructure around it. There's parsing, data processing, handling of updates, mapping, all that stuff. The important thing is right here. See this? It says Widget Tickers Live. That's a widget schema. Your web agent, the one you're programming, has 2 layers of life. The back end, which is its contract, and the front end. Everything in STELS is built around a unified web technology. It's all designed so you can build apps, contracts, dashboards, analytics panels, whatever you want, all in one place, for yourself, your clients, or even for government use. It doesn't matter, because STELS will also be used in government systems. We're already in discussions about that, and we're moving step by step toward regulatory integration, and STELS is well prepared for that. Now let's look at our agent. There were some logs. It's been doing something. I'll clear the old logs. Now I want to run this script. Start collecting data. All right, I'm launching it. This is just JavaScript. It's strongly typed, and you can't break anything here because under the hood, the runtime is built in Rust, and it uses meta macros. Those macros expect only the structured data that you're allowed to send. Technically, you could even send something like a paper note. Just kidding. But seriously, any programming language can work as long as the macro understands it. So, let's run it and check the logs. What do we see? It started making a connection, opened a socket, subscribed to a channel, and created a connection ID specifically for this exchange. In this case, it's a Bybit socket. We've already told it. This is your ticker pack, this is your contract. Here we have the configuration panel. There's also a prompt field for you. We'll work with that later. Now let's check the logs. Everything looks fine. Everything executed successfully. There's just a lot of logs here from those 14,000 operations we ran earlier. The worker is kind of overloaded, as you can see. That's because there's a stream running under the hood, so it takes a bit longer to load. But give it about 10 minutes. It'll clean itself up automatically. Here we can also check the leader. In our case, it's just us. So we launched it. Everything's good. Let's go back to the canvas. Inside the canvas, we have keys, some connections, the testnet, node info, and the runtime. The runtime is what actually manages the execution of your workers. You define the channels for that runtime manually. To access and use it inside the canvas, you simply need to specify the channel. We'll talk about that more later. For now, we've already programmed it. The runtime channel, spot, and here's our ticker. Let's make it more visible. Here it is. Testnet runtime ticker, Ethereum USDT Bybit spot. Perfect. We can drag it here and see what's coming in. Now we're getting all the information from the connector we just linked. So what do we see here? We see that it has its own channel, its own module, the ticker module. Then we have widget data, exchange, market, price data, the last price, bid, and ask from the order book, the 24-hour change in USD, the percentage change, the 24-hour trading volume, volume in USD, and volume in quote. And of course, latency. Right now, we're not on VPN and recording, so latency is a bit higher. When VPN is off and we're connected directly to the server, latency drops down to almost zero. It also shows that the ticker is active, its timestamps are updating, everything's working fine. Now we can continue working with it. Let's say I want to add a few more tickers. Right now, we have Ethereum. As you can see, runtime spot. Only one ticker here, Ethereum. Let's add more. We go back to the contract, set it to single, build it again. We double check that it's single. Sometimes there's a small bug, we'll fix that soon. Now I'll add another contract and call it BTC. Same setup. I save it, and let's add one more. In the prompt, I'll specify that this one is the Ethereum USDT ticker. These are the communication channels for the agent's brain. We'll talk about that part later. And here we'll add the BTCUSDT ticker, also a separate channel. We save it, check the code, make sure everything looks good, and run it. Let's see. It connected to Bybit successfully. Everything works fine. The whole process is highly optimized because under the hood, it's powered by a Rust engine and it's incredibly fast. All right, so we're all connected. And what's next? We now have two tickers that we've programmed together. It's lagging just a little bit. That's fine. It's because of the huge number of logs being processed right now. Let's open up the system and switch to the canvas. Here in the canvas, we can see that our ticker is already there. We can't drag it again because it's already on the canvas. But there's another one. Let's add it as well. Now, you can see a connection between nodes in the spot market view. We'll talk more about that later. That's part of visual programming, and it'll take a bit more time to explain properly. For now, we're just getting familiar with how the interfaces and the web agent programming process work. All right, we've placed two tickers. Let's add one more. Let's make this one SOL/USDT ticker, our Solana, the techie one. It'll connect and start fetching that data continuously, either from the network or locally. Now, when you send that socket connection, if the system sees that a channel already exists, that someone is already feeding data into it, then based on latency optimization, you'll get the data from that node instead of opening a new socket. That's part of how network data distribution works. We'll go deeper into that in another session. There's going to be a lot of sessions like this, trust me. All right, let's check our configuration. Leader, single, good. Prompt, present. Let's go ahead and run it. It connects much faster this time because it detects open sockets in the network and automatically picks the most optimized connection. And there we go. It's connected. Next, we have filters here. We can filter by stopped or active, by scope, network or local, and by workers, the contracts we're using. Here we can also see detailed statistics for each of these workers. You can see we have 2 workers below, each with just one operation because they simply opened, connected, and went live in the network. All good. Now let's go back to the canvas and check what's happening in our runtime. Spot, and yes, there's our third ticker, Solana. It also shows a spot connection. And more than that, I think soon we'll also see a connection by exchange, but that's part of the programming logic. For now, we can see it by module, and that's fine. We'll discuss this later. All right. Now, when you're working in the canvas, remember, you can build as many panels as you want, completely custom ones. For yourself, for enterprise clients, institutions, whoever needs them. You can create different dashboards. We call them panels. Let's create one, for example. My tickers panel. We'll save it. It's empty for now, just a default panel. I can delete it if I want, just to clear the space, and then fill a new one with my tickers. Perfect. All right, all the tickers are connected. The system is now fully running, collecting data under the hood and processing it in real time. Now, since we're developers, we need to understand a few key things. First, we can work with this data. We can aggregate it, transform it, do whatever we need with it. All the data runs with ultra-low latency. You can see here, it's connected to the lowest latency source available. Right now, every ticker is updating in real time. You can literally watch it happen. And here's the main thing. We've already learned how to collect the data, we've got it inside our channels, it's flowing across the network. Everything's running great. And in production, you might have hundreds of thousands of sockets connected to different exchanges or services. You can build an entire app ecosystem around this. For example, I'll deploy about 200 to 300 ready contracts on the testnet, so you'll be able to work with live market data right away. Or maybe not just markets. We could use a healthcare example where you monitor a person's vital signs while they sleep. That's just an example. But the point is, you can connect to any real-time interface, process the signals, and visualize them in your system, because everything here runs on high-frequency protocols. All right, that's cool. Today we're focusing on the core functionality, how to build an interface with our small web agent, the one that collects and aggregates data. The goal is to understand that this whole system runs on scripts, and you can work with them however you like. There are templates, there are custom scripts. You can program absolutely anything you want. Let's say I create a simple custom script right now, just to show you how I can aggregate all tickers into a single interface. It's just an example. We'll go deeper into that a bit later. Now filtering, everything should be right here, live. At the moment, my analytics hasn't updated yet, but you can see 1 worker is stopped, 3 are running. And you can check the number of operations executed by the current node in the network. Now let's move on to the interesting part. Once you've built your scripts, collected a bunch of data, maybe listening to your neighbor's Tesla or your own, or watching your cat sleep, whatever. In our case, we're working with market data. So what happens next? We need to visualize all of this inside a working interface so it actually looks like a proper application. Now, how do we do that? Usually you'd open an API, hire a front-end developer, pay them a bunch of money, and in the end, who knows what you'll get or whether it'll even work properly. Honestly, I've never liked that approach. I've been a developer for almost 20 years. Actually, more than that. And after working with so many different developers, I realized something. I want to teach you how to work with data yourself. It's actually very simple. If today you're just a regular trader, you can become a cyber trader, a trader developer. If you're a developer, you can also become a cyber trader from the developer side. You can learn to trade using automated control systems and collective intelligence management. That's the key idea. Now let's move to schemes. So what are schemes? Think of them as a data constructor for your web agent, a visual layer that defines how your agent presents and operates. You can use them in connection with 2 forms of applications. The first form is the application itself, the one that goes here into the main interface. The second one works inside the canvas. Both types of apps run in runtime, because STELS is a living organism. It's protocol-driven. You write a protocol, the system validates it, connects you, and delivers your data. That's it. Go ahead and work with your data. The most important thing in STELS is data. Data it can collect from anywhere. Honestly, I don't even know what it can't collect data from. This is runtime engineering. It's all about practice and flexibility. So yes, we can collect anything. Now, moving forward, to use the system fully, you need to understand that we built a lightweight, simple engine for creating web applications. Think of it this way. There's Apple, and Apple has iOS. iOS has Swift. You write in Swift to get into iOS to get into the App Store. That's the entry point for Apple. Same with Google and the Play Market, same story. But on the web, there's no such thing. So I thought, why not? Why shouldn't we have that? And with web agents on top of it, let people build their own apps for the web using classic web technologies. It's all about having a clean, professional, high-quality idea. You can work with your scripts, your workers, your smart contracts, your web tokens, trade, automate, and build whatever you want. And on top of that, you can visualize it and turn it into full-fledged applications. Now let me show you how that works. So, agent schemes come in two types, static and dynamic. A static scheme is a bundle that can only hold itself. A dynamic scheme can include other dynamic schemes, but not static ones. Why? Because dynamic schemes live inside the canvas, right here. Static schemes are the bundle of your app, and they go here, into the web store, a full-fledged Web 5 store we're currently testing. Once you create a static scheme, you can immediately publish it to the web store through your node. And when the global store goes live, your app will appear there, and you can sell it. Whoever uses your app will simply subscribe to it and pay you directly in our native tokens. All right, let's start with a static scheme. A static scheme is basically the name of our web agent's application. To make it visible in the App Store, we need to give it a prefix, app. Then we can name it, for example, agent tickers. These protocol rules will all be published in the documentation, so don't worry. You'll be able to read through everything later. All right. Bam, we hit create, and here we go. On the left, you can see a declarative JSON-style code editor. That's how you build your interface. On the right, you see a live preview of your generated interface. Why does it work like that? Because this system is built purely on web technologies, JSON plus Tailwind. You write it. It renders here in real time. Everything you define is immediately displayed. You can describe exactly how you want your application to look, and it will generate it for you visually. This is a secure schema-based system designed to let you build heavy, high-performance enterprise products that process live data safely. For example, I can build a UI right now. Let's call it Welcome Web 5 Agent or maybe Tickers UI. I'll make the text size 3XL, bold, and done. The schema is ready. Now I can design anything I want here. Let's add another line. I'll just type ticker, make it smaller, and maybe set the text weight to 600. Done. I've just created my first app layout. This application is now visible in my local web store. Let's check it. Yep, here it is. The first web agent app, web agent tickers, and it already has its own communication channel. Now, when we open it, we're inside this app. If you log in as a regular user, not a developer, you'll only see this app. None of the extra developer panels. Those are only visible in the dev environment, not in the production web store. From here, users can already start interacting with your app. All right, switching back to my developer account so we can continue. It's already 5:30 a.m. here, so I'll talk for another 20 minutes and wrap up. And the next session will be tomorrow. Now, we're back in local net. Everything's fine, and our first app is running. At this point, we can move on to dynamic data, because even inside this static app, we can work with dynamic content. On the left, we have interface tools. Let's talk about those for a second. We can create a new interface or edit one, say Web Agent, and save it locally while it's still in development, before deploying it to the network. Next, under Info, we see details like connected channels, creation and update timestamps, its unique identifier, documentation links, and a full list of declarative methods. There's also an option to delete the scheme. Below that, we have compose schemes, nested components that can be reused inside other schemes. You can also set up a main data context, and here you'll see all your channels. Let's save this so we don't lose progress and switch over here, where we have our 3 workers, our 3 contracts. all fetching live data right now. See, we've got our Ethereum USDT channel, our BTC USDT channel, and our Solana channel. When we open the scheme, we can connect to any of these channels. For example, I can make this one the main self channel. Let's say it's Bitcoin. I can also give it a variable name like BTC. Wait a second, since it's already marked as self, I can't assign another variable yet, but we'll get to that a bit later. Inside the declarative UI, I can now use this self data context. Here below, you can see all the available fields from self. This shows that the BTC USDT channel is now the main context, and we can access its live data. For example, I can write self.raw.data.last that pulls the latest tick value directly from the live feed. Let's call this base ticker. All right, let's make this look a little nicer. We'll wrap it inside a children object. Now we've got a nested scheme, and here we can do something beautiful. Let's combine it like this. We'll create two data types, and I just want to position them neatly. I'll remove this part from here. And over here, I'll label this block base ticker. I'll remove all the extra text, don't need it, set it to flex, and give it a gap of 4. Now, what can we do? We can style this ticker. Let's call it base, just to keep it clean. All right, looks better already. I can now format this ticker. In the documentation, you'll be able to play with all the options later. But here's a simple example. Let's say I want to format it as a number with 2 decimal places. I'll add a small formatting rule here and drop it right where I'm using self. You can, of course, format it however you like. 4 decimals, 8 decimals, whatever fits your logic. Now, what else do I want to add? I don't really like the color. I want it to reflect the current data state. For example, is Bitcoin going up or down right now? Just an example. We can define operations that dynamically change colors based on the data. Let's add that. Here I can check the percentage change value. If it's negative, it's red. If it's positive, it's green. And now, the valid ticker knows exactly what's happening. It displays red if the asset is down, green if it's up. All of that logic happens automatically under the hood. Perfect. Everything looks good. Now moving further down the hierarchy, we'll start building a line of tickers for monitoring. And not just for monitoring, because each object can have an event attached, and that event can trigger a back-end function. So that's how back-end and front-end are connected into a single operational system. You can create a smart interface where clicking a button can trigger actions like buy, sell, or place order, whatever you want. You can design it freely. All right, cool. I've created 3 basic components, blocks that use both static and self-based data. I'll save it. And here's what happens. See this? Here's my widget. It's live. And users can already use it to see the current Bitcoin price. That's just an example. Moving on. Nothing here has changed yet, right? Not great. I want it to look more beautiful, more human, so to speak. To fix that, we'll now create a dynamic interface, a dynamic scheme, and link it to our app, and also to the canvas. Let's go. We'll name our dynamic scheme ticker.live. To link an interface, we have widget fields. See these data fields here? This widget is called widget.tickers.live. All right, let's build it. We'll go here and name it widget.tickers.live and call it ticker.live for short. Create the scheme. Done. Here's our new widget. It's live, but still empty. Now let's attach a ticker to it. We'll set it as self because this ticker will be reused across different widgets, each with its own self context. Right now, this one is BTC. At the bottom, you'll see self.raf.data.last. That's the current live price feed. Let's remove all styling for now, keep it clean, and then add back a bit of formatting. I'll also add another value, the percentage, self.raf.data.percent. You can copy it just like that. Just remember to remove the extra brackets. Now we can define a simple rule. If it's greater than 0, color it green. If it's lower, color it red. All right, let's save it. Now look, when we go back to our web agent, to our scheme, we can see a nested scheme has appeared and we can attach it. Let's do that. we'll pass the scheme itself right here. Kind of like we're linking a reference. There we go. We just write refarrowWidget.tickers.live. Pretty cool. You can experiment with it as much as you want. So what's happening here? Right now we've got Bitcoin and it's pulling the self data from here. But we can reassign that self directly inside the ticker. We can say, all right, you're using self but also connect it to the Solana channel. Now as I switch self, boom, Solana appears. And yeah, Solana's in the red too. Not bad. And if we go back to Bitcoin, there we go. Now, what can we do next? Let's add another variable. I'll call it sol, and say sol.raw.data.last. Now we've got two tickers. I just want to show you how we can use self both in the main context and modify it dynamically. You remember that our widget was given the channel widget.tickers.live, right? Now, if we go back here, look what happens. We see all the self context for each of these objects and the complete data object that's stored in that variable. Ideally, this should be separated for cleaner rendering, since the system doesn't format multiple layers at once. But for now, it works. Now, if I place just one ticker, why isn't the formatting working? Oh, right, my bad. The percentage field isn't here. Let me fix that. Okay, now I'll move the formatting over. Let's test something. If I take sol.raw.data.last, does it format both? Yes, both are formatted. Nice. So what I wanted to show you here is that we placed an object with its self-context coming directly from our widget store. Now if we delete the widgets we built, go back to runtime. Spot, and open our tickers. For example, Ethereum and Solana. We can continue working with this dynamic widget, styling it however we want. Let's say I add a class name and pass Tailwind styles like P4. Save it. Check the canvas. Wow. Looks pretty cool, right? We can stretch it, make it look even better. We can also add more data, like self.raw.market. Oh wait, forgot to create a proper object for that. Let's fix it quickly. We'll make a div, add the text, and bind it to self.raw.market. Done. Not perfect, but it works. Let's also add some padding for consistency. Save it. Go back to the canvas. And look, our ticker is rendered. Now any ticker you pull from the system will automatically render this way, based on its self-context. From here you can build trading strategies, linking them together. Each object already has its own structure. Later, using these structures, you'll be able to deploy your own contracts. That'll be in the next lesson, where we'll build web tokens and program market management strategies like a market maker strategy. We can also disable nodes just for testing. And of course, you can build an infinite canvas with multiple tickers and data links. I'll later show you how to program those connections, the logic, the events, all of it. Now, in the widget store, users will see this assembled app we've just built, and they'll be able to use it directly. Styling and visuals aren't the top priority yet, but we're already close to releasing the beta version where you'll be able to build full applications right inside the runtime. Once your app is published in the store, any user can open it, subscribe to it, or just use it freely. Together with the STELS team, we're building a decentralized, distributed web, the next generation Web 5. I'll really appreciate your feedback. Let me know what you think about the project overall. Next, I'll teach you how to program contracts, web tokens, connect everything to the core logic, and even build a DEX or swap app. We can literally build a swap between Ethereum and Bitcoin, and even Bitcoin to gold, in about 15 minutes. It's all possible because STELS supports a full runtime infrastructure where you can execute anything you imagine. More details are in the documentation, including full Web 5 standards and implementation details. We'll be adding release documentation soon. So expect the first beta release in the coming days. Submit your request to get a node, we'll review who you are and what you do. And once you're approved, you'll get your node, and we'll start building the modern Web 5 together. Thank you.